So this video will introduce how to program and run the VEX IQ robotics system using your iPad. So we'll talk about how to connect the VEX IQ robot brain to your iPad, how to set up the motors so you can control the motors on the robot, and look at how to do a really simple program. Basically just drive the robot forward and make it turn 90 degrees in order to drive it in a square. Okay, we will tackle how to connect sensors to the robot in a later video. So let's get started. We go firstly to devices over here. And from there we have to decide whether we have a first generation or a second generation VEX IQ. So it's pretty easy. If your VEX IQ robot brain has a black and white screen, it's a first generation one. If it has a color screen, it's a second generation. So in my case, it's a second generation robot. So I make sure second generation is selected in blue, and then I get out of there, go up to the top where it says brain, and connect to IQ. And I should probably say here the robot has to be switched on, obviously, for this to work. And then the robot, in our case, has been given a name that reflects which of the class kits we're using. So this robot's coming from kit 4, so it's called kit 4. So we press on that, press connect. When it does that, it'll come up with a 4-digit code on the screen of the robot, and you just have to enter that into your iPad, press submit, and then you connect it. From there, before we can do anything else, we need to tell the iPad app which devices we have connected to the robot and which ports they're connected to. So we go to devices again, we go add device. Now there are plenty of things we could add here, motors, sensors, etc. We, for today, are just going to look at setting up the motors so we can drive the robot backwards and forwards. So it's a 2-motor setup. So we're going to select drivetrain 2 motor. And in the design we're using, the left motor is connected to port 1, the right motor is connected to port 2. And then our next option requires a little bit of thought. This is about how we're going to control the turning on the robot. So by default, that's the no gyro option. The robot does not know exactly how many degrees it turns by whenever it makes a turn. If you enter in the correct details about how big the wheels are, how far apart they are, you can get it pretty close to, say 90 degrees. If you set up properly, it'll turn close to 90 degrees, but it's never perfect. It's quite fiddly. So a better option is to use a sensor that allows you to determine how far the robot's rotated by. So if you have a first generation one, you can use a gyro sensor to measure angles of rotation, or if you have the second generation one, it has what's called an inertial sensor built into it, which does the same job. So I've got a second generation robot, so I'm going to choose inertial brain. And then the last thing I have to do is tell it basically enough about the drivetrain that it knows how much it has to turn the motors by in order to drive forward by a certain distance. So if I want to make it go forward by exactly 30 centimeters, it needs to know how big the wheels are and whether the wheels are geared up or geared down. Now in this case here, the design we're using, the robot wheels are connected directly to the motor, so there's no gearing involved. The wheels haven't been geared up for for speed or geared down for torque. They're just connected directly to the motor. So we choose a 1-to-1 input to output ratio. And then for the wheel size, generally with these kits you can look on the tires and they'll have printed there what their circumference is, right? Now in this case here, the robot tires we're using have a 200 mil circumference, so we just leave it at 200 mils. And from there we press done. So now the robot will be able to control the motors, make it drive forwards, make it turn. We might just do a simple program that drives the robot in a square. So we do that by using code blocks. The code blocks are separated into different categories which are color coded. You can see them on the far left of the screen. And we have sort of like the guts of our program is always the event ones and the control ones, which are light orange, dark orange. And you can see our program already has a light orange when started block. So this is like the beginning of most programs. So what we're going to do is, we'll come back to that in a second, but we're going to actually go to the dark blue one, which is drivetrain. And just because I want it to do pretty accurate stuff, I want my square to be pretty close to perfect, I'm going to slow it down a little bit because I find that the robot tends to drive a bit better when you don't try and make it go too fast. So I'm going to set the power for driving and the power for turning to 50%. That's going to be the first thing I do in my program. And then after that, I want to drive it in a square where the sides of the square are all 30 centimeters or 300 millimeters. So I'm going to select the block that says drive forwards 4, and then I'm going to click there where it says 200 and set that to 300 millimeters or 30 centimeters. So I'll make it go forwards by 30 centimeters, and then I'm going to make it turn to the right by 90 degrees. And then if I do that 4 times, so drive forward, turn 90, drive forward, turn 90, and so on and so on and so on. If I do that 4 times, I'll get a square. Now I could just repeat this block of code 4 times, but that'd be a bit wasteful. It's probably more clever to go to Control, choose the one that says repeat, put the code I want to repeat inside there, and then if I want to do a square, I'm going to repeat that 4 times. And then put that there like that. So now I've done that, that's going to be my code. I just need to save it and then get it onto my robot. So to save, I press up the middle where it says VEX Code Project, and I'm just going to call this square and save it. When it does that, it'll want to know where to go. I'll just put it in the recents. So I'll press the plus there. I'll give it a file name. I've already created a file called square earlier, so I'll just call it square2, whatever. Press OK, and now it's saved. Now I just need to download it onto the robot itself, so I select where it says download. Only takes a couple of seconds. And then from there, I can either run the program on the robot itself by using the keys on the robot to select the program and then run it, or I can do it directly from the iPad. In this case here, I'll do it from the iPad by pressing the run icon and then let it do its thing. And then we can see our robot has successfully completed pretty much a perfect square. Not entirely perfect because like I said, it's always about turning through exact angles and that's hard to do, but pretty close to it. So that completes our video.